All right, so today we have Bryan Cantrill, CTO and co-founder at Oxide Cloud Computer. The tagline is no cables, no assembly, just cloud. And just to kind of burnish his credentials here, for you youngsters out there, Bryan was a distinguished engineer at Sun Microsystems. I'm old enough to know back in the day, in the late, I was in the valley towards the tail end of the dot-com era, and let's just say the entire dot-com was run by Solaris. Um, and actually, if
True.
you were to tell me, if you had told me back then that Linux would have taken over, I would have laughed at you in the face. At that point, Solaris seems so far ahead. And more recently, he was CTO and SVP of engineering at Joyent, which is infrastructure as a service and private cloud, eventually acquired by Samsung. So, with that long-winded introduction, welcome to the Data Exchange podcast, Bryan.
Oh, great. Thanks for having me. Yeah, fun to reminisce about the dot-com boom and bust, which still it feels like it was recent, but it really wasn't. It was a long time ago.
No, I mean, I'm serious. I mean, when Linux first came out, I'm going, oh, this is great for kind of playing around. But really, where Solaris is.
Yeah, I mean, I gotta tell you though, it was more about x86 and Spark than
Yeah.
and on we at I think so I was in the operating systems group at the time at what was called the Planets at Sun. I was at Sunsoft at Sun Microsystems, and we were using x86 boxes because Solaris ran on x86 in addition to Spark. And boy, the price performance of x86 was just thumping Spark. And we were really trying to sound the alarm bells that and I thought to myself, hey, if I were to do something right now, I would do it on x86, not on Spark.
Right, right. All right. So again, go back to the tagline of the current company, Oxide Cloud. No cables, no assembly, just cloud. Tell our listeners, what problems are you folks trying to address?
Well, so importantly, it's actually the name of the company is Oxide Computer Company. So we are very much, and that's a very deliberate nomenclature. We are very much a computer company, and our big belief is that the definition of the computer has changed and expanded to include elastic infrastructure, and that elastic infrastructure, which is to say the ability to have API provisionable compute, storage, networking. That's here to stay. That's a very important development. And right now, if you want to do that, you're going to do that basically in the public cloud. And the kinds of machines that folks that are in AWS or Google or at Microsoft, Meta, the kinds of machines that those folks have for themselves upon which to deploy elastic infrastructure look nothing like the machines that you can buy to run your own DC. So our two big beliefs as a company were that cloud computing is here to stay, and that Andy Jassy is not going to actually run every computer on the planet. There is still remains a need for people to actually own and operate their own computers in their own data centers or in their own co-located data centers. And those reasons can be, there are many reasons. They can be security reasons, they can be risk-related reasons, regulatory reasons, and increasingly, they can be economic reasons, just the economics of renting all of your compute, just like the economics of renting anything. Renting makes sense. If you need to rent a car and you're in a city you haven't been in before, renting a car is going to make a lot of sense. You're going to be driving a commute every day for a couple of years. You really don't want to do that in a rental. You want to actually buy a car. And we think compute is the same way. You shouldn't need to rent all of your compute. And it makes a lot of sense to actually own it. But if you do want to own it, you really want to have a computer that is able to be cloud by default. That includes all of the software you need to actually go provision virtual compute and network and storage.
So I think people who are in the AI ML space, enough of them understand the need to not necessarily do everything in the public cloud. So, Bryan, so what is the state of affairs prior to Oxide? So, In other words, for people who were in a position where they had to do certain things
Yeah.
themselves, what was the default?
Well, the default is, you're in the kind of the world of Dell, HPE, Supermicro, and you are buying what is effectively a personal computer. It is a rack-mounted personal computer. It looks like a server, but architecturally, it looks like a 1980s, 1990s era personal computer. And there are, a bunch of kind of legacy historical reasons for that. But in particular, and importantly, that computer does not come with an operating system. Yes, Dell or HPE may be willing to bundle Ubuntu or Windows for you, but there is no co-design with respect to that computer and its system software. And that becomes really problematic because you, as the end user of this infrastructure, you are responsible for not just the operating system, because the operating system, I mean, boy, the operating system is super basic compared to what we need to go do today, where you need an entire distributed system to actually allow multiple tenants to provision and deprovision infrastructure. And then that's for compute. And when you add virtual networking and virtual storage to it, you now are responsible for you buying this personal computer. You've got to either go buy software from the likes of VMware, now Broadcom, or you've got to go roll the dice with a bunch. You can try to do OpenStack and Ceph and so on, but it's very much a kit car at that point. And getting it to work at a rack level, maybe you can get it to work with a rack or two, but you start to get, multiply that times many racks, and the support burden goes way, way, way up. And that's just all this mess that needs to be managed. If you look at the actual hardware, the actual hardware really is not designed to operate at scale. And we talked about our tagline in terms of eliminating cabling. The cabling that we eliminate, let's get a little bit specific about that. I mean, if you look at the back of a commodity rack today, you see tons of cables. You see tons of power cables. So all of these little 1U and 2U servers have AC power coming into them. So you've got a PDU that's got AC power. So you've got power supplies, redundant power supply, because the power supply is actually the component that's most likely to fail. The fans in particular are likely to fail on that power supply. So you've got redundant power supplies per server. And that you may well wonder is that an efficient way to do it? And no, it's not. Anyone deploying at scale, and I'm talking even modest scale, doesn't do it that way. They've got a rectifier, a shelf of DC rectifiers that you've got your AC in, and then you're running DC up and down a bus bar. And then you've got your compute elements blind mating into that bus bar, that DC bus bar. Way more efficient. You cannot buy a DC bus bar based system from Dell, HPE, Supermicro. And that's just the beginning. I mean, you look at, and we've eliminated networking cabling because we have a cabled backplane. You blind mate into networking. When you are actually able to design at the rack level, there are a bunch of things that you can actually design into a real product, such that asking about the state of the art today, you as the end user don't end up being the integrator. Because by the way, when you're the integrator and it goes wrong, and you're like, hey, I went to go provision an instance this morning and it didn't work, or it took 3 minutes, everybody's going to point a finger at somebody else. VMware's going to tell you it's a Dell problem. Dell's going to tell you it's a VMware problem. Maybe they'll both tell you it's a Cisco problem. And you are left trying to figure out where the actual root cause of this is. And and then of course the economics are not great, because you are paying pretty expensive software. And so there are a bunch of reasons why the state of the art today is really painful, especially when you get to any kind of scale.
So with the rise of AI at scale, so there are, I guess the best description would be appliances or racks of appliances, right? So the example that comes to mind is Cerebra Systems, right? So they'll sell you a rack of 1U, 2U machines that contain their system. And, you can go nuts and train as large a language model as you want. But it's not general purpose. It's very specialized for that one thing. So what you're describing here is, basically cloud computing. You got storage, networking, you got compute. Um, and so why now? Why, I mean, why didn't someone else, why didn't the Dells of the world uh,
Oh boy. Yeah. I
have an
mean, so
offering specialized for this? And by the way, so two questions. Why now?
yeah.
And is the demand big enough to actually justify doing a startup?
Yeah, for sure. Two great questions. Yeah, I feel like this is you're going harkening back to when we raised our first VC round in 2019. I feel like you're asking good venture capitalist questions.
Yeah.
Yeah. So on both of those. So on why now? I'll tell you that many technologists, either technologists who are on kind of the server side in the vendor space, or technologists that are actually deploying this stuff in production. Their question is like, why wasn't this done a long time ago? Like, why am I still suffering in this kind of pain? And why has nobody done this? And the answer in terms of why nobody has done this, and folks have taken various swings at it requires two things: hardware, software co-design, which is really hard. And it kind of runs counter to the way certainly the personal computer has run. The personal computer succeeded because it actually separated hardware and software. So I always find history has a lot to tell us, and the history of Compaq in particular is really interesting. Compaq rocketed.
And by the way, for
Yeah.
our listeners, it's not just hardware, software co-design. They're optimized to work well together, right?
Optimize and integrated. I mean, it's
Yeah,
not
yeah.
even. You got optimized only from a performance perspective, but the idea that like no, this hardware is built for this software and this software is built for this hardware. That specificity allows you to get a unit that you can really test and develop. Compaq actually rocketed to success by introducing a very firm boundary in there, and by putting a lot of firmware in that server that allowed it to run really Microsoft Windows, but the software was being developed by Microsoft and delivered by Microsoft, and the computers were being developed by Compaq and then Dell and then HPE, and there was a lot of consolidation over there, but there was this big divide, and a divide that HPE and Dell are effectively afraid to cross. Dell does not have its own hypervisor. HPE does not have its own hypervisor. So even at the most basic level, they view the delivery of system software as somebody else's competency, somebody else's responsibility. And of course, Microsoft was very happy with the state of affairs because they get to be in this kind of high margin software business, and they which doesn't have the kind of the grit associated with that with actual hardware, but it's the customer that suffers with that gap, because these things aren't actually co-designed and they don't necessarily actually work with one another. So it's very, just that gap is really hard to bridge. And Intel had this rack scale design effort, which was had some of the same principles that Oxide had actually, but they deliberately, because Intel didn't want to alienate Microsoft, didn't want to be seen as kind of picking winners among their software ecosystem. So there's no software component to the Intel rack scale design. It's like, that's going to fail. You cannot solve rack scale design in hardware alone. You also cannot solve it in software alone. And that's what we had attempted to do at Joyent, where we were really attempting to solve it in software alone. And the big eye opener for me is like, no. When you've got this downstack system that is designed to work with quote unquote any operating system, the way it pulls that off is by pulling in a bunch of software that you can't see and can't control and can't audit into this thing called firmware. So there is a UEFI bias down there that is an entire world of, as it turns out, vulnerability, as we've seen recently. There have been a lot of UEFI vulnerabilities, but that's because there is actually system software that Dell and HPE ship. It's in the BIOS, and that's a huge problem. And you need to actually, in order to be able to solve this problem correctly, you got to nuke the whole thing. You got to start from the building blocks of the microprocessor. You got to have the guts to chuck the BMC, is the baseboard management controller, made by a company that most people haven't heard of called ASpeed. If you've heard of ASpeed, it'll make your eye twitch, because they deliver very expensive, very bad silicon with software that historically has been entirely proprietary and rife with vulnerabilities. You've got to be able to get rid of that ASpeed BMC. You've got to do your own board design. You've got to then do all of your own system software. And the reality is that is very disruptive for an HPE or for a Dell to do this. It's the classic innovator's dilemma. They would be disrupting their own businesses. They are very afraid of disrupting their own relationships with Microsoft and VMware. I mean, even still, it's kind of shocking. Even with VMware now acquired by Broadcom, there is still a sense of like, we can't alienate them. It's like, okay, then you're not serving your customers.
So still, why now?
Why now? So why now is it honestly has, I think, taken this several years of divergent paths to build up all of this pressure. And the pressure is that on-prem compute has been left behind, and the cloud compute that you rent is living in modernity, and on-prem compute is living in antiquity. And that needs to be bridged. And I think in terms of, you were asking also, like, is there demand for this? What we have known is, yes, absolutely, there is demand. That demand, again, may come from regulatory concerns, security concerns, but the other demand that we knew was coming were that economic concerns, because we had seen this over and over and again. The reason Samsung bought Joyent is because of their AWS bill. And they needed to go buy a company in order to be able to get out from underneath their AWS bill. Buying a company is not an option for many companies. There is no real product in the space. So we knew that the demand was there. Ironically, when we initially raised, venture capitalists were like, well, look, technically, we know you can do this. Technically, this is straightforward. And I'm thinking to myself, I'm not explaining this very well, because technically we're doing our own compute sled, our own board design, our own service processor, our own hypervisor, our own control plane, our own switch operating system, our own rack, it's like, no, technically this is like beyond the brink. But they would say, so technically we don't have any concerns, but we don't think the market is there. And it's like, ironically, the market is emphatically there. It is the technical hurdle that is really, really tough. This is really tough to go do. The minimum viable product, I mean, it took us 3.5 years to build the minimum viable product. We just shipped into the market late last year. So it's like, it is really, really hard to go build. And it's kind of in this worst possible zone where it is too big, honestly, for a startup. It's challenging for a startup. You need to have the right kind of, God bless our investors. You've got to find the right kind of investors who see that market, who have an appetite for hard tech problems, and are willing to have the patience to go build this right. So you need to find the right investors, and then you need to build the right team. And that's really hard. And if you look at a bunch of companies have tried, and I think I spoke to all of them at some point before we raised. I wanted to understand, why have companies not succeeded in this? And it's ultimately boils down to, it's really big and really hard. And you've got to. We kind of took all that wisdom in when we raised and when we built the team, and we've been able to cross the chasm in terms of actually having a product that is now running in customer data centers, which is very exciting.
So a couple of questions. So does the rise of AI, generative AI, add even more demand for Oxide-like solutions? And secondly, does your minimum viable product address ML and AI workloads?
Yeah, two great questions. I mean, I'll take the second one first. So we were, as you can imagine, looking to reduce scope wherever we could. We're being so ambitious. And one of like the really natural scopes to eliminate is like, we're not going to have a GPU. We are only going to be a CPU based product. So this first Oxide rack, these compute sleds all have a general purpose AMD Milan 7713P CPU. Now, we think that there's lots of space in the market for the general purpose CPU workloads, and there's a lot of inference you can do with general purpose CPUs. So there's a lot you can go do with that.
As I wrote about recently, actually. So there's a lot of interesting work around, the same tricks that people applied to computer vision, they're revisiting for LLMs, right? So there's a sparsification, quantization, and so on.
Totally. And the quantization stuff is actually, it's really interesting in terms of what you can do. And because like the kind of the compromises that you end up making to get these models a little bit smaller, to get these models able to run on to leverage what the CPU can go do. So also you have the instruction sets have been extended over time to accommodate these kind of workloads. So you have some really interesting instruction set capabilities. I also feel like the advantage that CPUs have is like, they're available right now. I think in many ways, the best thing that has happened is the explosion in demand has made the GPUs so difficult to obtain that they have forced people to like brainstorm other solutions, which is great. And like, by the way, that's how we got here to begin with. We got here with ImageNet in 2012 and thinking like, hey, I got this gamer stuff sitting around. Can I put these PC gamer technology, can I put that to use solving some of these?
I mean, actually, setting aside even the specialized accelerators like Cerebrus and things like that. I mean, a lot of energy going into, inference for CPUs, but also for AMD GPUs, honestly.
For AMD, and so then I think that we are now, all of that said, so we've got no GPU in this product, only CPUs, but we're obviously really interested in what's happening out there. And what I am especially interested in is the MI300A is really, really interesting to me. And I would be really curious about what your listenership thinks about this. We actually did a conversation when they launched the MI300A. We did a conversation on our podcast about it. And, I think that, so for those who are unaware of it, so the MI300 is their next gen GPU, AMD's next gen GPU. The MI300A is taking an APU approach where you've got GPU chiplets sitting aside general purpose CPU chiplets. So you've got a package that has both general purpose CPU on it and then a lot of accelerated compute. And it's like, boy, does that feel like the right answer to me. I mean, it just feels like pulling the GPU on package as a chiplet it just feels right as a technologist. It feels like you are solving the bandwidth problem. You are solving, I think that one of the interesting problems that these LLMs have is around model size. And it's like, actually, like, you should use the DDR5 that we use for the rest of the system. Like, why does your APU your accelerated compute should be able to have that same memory addressability? You should be sharing. I mean, this whole idea of like having effectively a disjoint address space for your accelerated compute as for your general purpose compute? It's like, no, why can't like our accelerated compute should be able to cohabitate with all of the memory we have for the system, and let's build a really unified system. So,
and as my friends at Lam and I point out, and they've partnered with AMD. A lot of people are under the mistaken impression that the software stack ROCm is way behind, but it's actually close to 80-90% there. And what they've done with AMD is basically close the gap with CUDA, right?
So and it's funny because of the way we kind of kicked off this episode, and you were talking about, hey, in the .com bust, it was all about Solaris. And if someone would have told me that Linux is going to compete with Solaris, and it was Solaris, and I would also say it was Windows, right? Those were the dominant systems of the day. Windows on the desktop, Solaris on the server.
No self-respecting .com would be on Windows.
That's true, with the exception of Elon Musk. Musk was a big Windows advocate
Oh,
at
really?
PayPal. Yeah,
Oh, really?
yeah. This is how you know that like Musk is just like, sorry, not one of the tribe. Like he's just the guy's just a bullshit artist. He's not. So yeah, the no, you're exactly right. Every self-respecting.com is on Solaris, and there was this
And
arrogant idea.
this is how ancient that time was. The databases were either Oracle or Informix, right?
Or Sybase.
Or Sybase.
That's right. Yeah. The No, I know. It's funny because like I mentioned like I think Informix and Sybase have very much dropped off. Like
And
no
they were all in the Bay Area having billboard wars, right?
Billboard Wars. Thank you, thank
Yeah,
you. Because like it's almost like a dream now, the
yeah,
Billboard Wars.
yeah.
And you described the Billboard Wars as a Gen Xer describing the Billboard Wars to a millennial. You sound crazy. And people are like, are you sure this happened? And I'm like, maybe I'm not sure this happened. Maybe it was a dream. But just for your listeners, there was a billboard famously called the FYO billboard, the Fuck You Oracle billboard, that was outside of Redwood Shores. And that billboard was owned by Informix. And they used to make fun of Oracle as you drove up the 101 past Oracle. Informix, and so like I mean, I'm sure you remember a couple of these too. They had a Dinosaur Crossing was one of my,
Honestly, Informix was a good system.
it was a good system, absolutely good system.
Yeah,
So they had Dinosaur
yeah,
Crossing, they had You Just Passed Redwood Shores, so did we, with
yeah,
their latest TPCC numbers.
yeah,
It's just like how great was the Silicon Valley of like the late 90s, early 2000s when
yeah,
people are putting TPCC numbers on a
yeah,
billboard. It's just like, oh man, that
yeah,
was it was good times. But then Informix was bought by IBM,
yeah,
and
yeah, yeah,
then
yeah.
IBM was like kind of making fun with Oracle for a while, and then IBM like chickened out, and then they were just like, it's
So
just not.
going back to Oxide. So
So
now
wait, so
you
so so well, here's what's
now
important.
you have a MVP, right? So
So here's what's important. So on that, like
yeah,
when you mentioned Rockham,
yeah.
and so during that era, Solaris in particular, and I was inside the Sun, I saw this arrogance that people had with respect to Solaris, and this idea of like we have 1,000-year head start over Linux. And we've put this many hours into this thing. It will never catch up. And it's open source. And it's like, these are all of the same arguments that people are making today about CUDA. And when people say CUDA's lead is insurmountable, and NVIDIA has put all, it's like that's all true. That NVIDIA has put a lot of effort into CUDA, and CUDA is extremely important. But Rockham is open source, and the pressures for people to be able to run this stuff on a GPU that they can obtain is going to be so great. And when you couple that with the fact that it's open source, anyone who believes that Rockham cannot catch up to CUDA would be wise to go back to that history of the dot-com boom and bust and realize that the same arguments that they are making in defense of CUDA are the ones that folks made in defense of Solaris and defense of Windows in the late 1990s. And so for that reason, I think you're right. Like I am bullish on, I mean, yeah, for sure, just like Linux in that time, there's a gap that needs to be closed.
Right, right,
And
right, right.
like is Rockham there yet? No. It's also like to a certain degree, like the gap is, I mean, this is running compute, right? So there is the gap is closable. This is not, it's not like there is a kind of a long tail of disaster that needs to be cleaned up. And this can be
And
closed.
you may not, you can incrementally close it, right? So maybe your software stack isn't as flexible or broad, but it can support enough of the models that people start using you for a certain amount of their workloads. And by the way, I've lost track of what is Intel's GPU. What is the state of Intel's GPU? They have their own stack, right? So one API, one their own software stack. But they might also, who knows, right? So
Yeah, I think that they're in interesting. I mean, it's out there, right?
yeah,
In
yeah,
terms of like Intel is out there as a joker in the deck.
yeah.
Intel has got paradoxically their own arrogance problem to deal with. And I think that they have been this narrative that they have that NVIDIA is lucky is a very dangerous narrative for a
No, no,
company to
that
have.
was, I think that was like maybe not something the rest of Intel wanted to be out there. Maybe that was just a slip by the CEO.
And well, I think that he hand on heart believes it. So he does hand on heart believe that NVIDIA was lucky,
Yeah.
and that if he had stayed at Intel, that NVIDIA basically wouldn't exist, which is bonkers to anyone who
Yeah.
knows the history of
Yeah. Yeah.
Larrabee.
Yeah.
I think it's so. I think that thinking is very dangerous, but as anyone knows, anyone would be unwise to underestimate Intel's ability just because the resources are so great. So they're definitely a joker in the deck. But right now, I would say this is coming down to NVIDIA versus AMD. And the fact that AMD is betting on open source, is betting on Ethernet, which I think is very important, and is betting on the APU and is betting effectively, albeit okay, that's a quieter bet on this idea of having accelerated chiplets living alongside general purpose chiplets. That to me is like pretty interesting, and I think that that's part of what we've been very careful about is like in order for Oxide to enter the space, we are going to have to like bet on one of these, right? We can't. Our approach when we have built this, in because it has to be, is like we can't support everything. We've got to pick winners. And so there are no Intel CPUs. We don't have Intel CPUs in the Oxide rack. It is only AMD CPUs. We did the analysis in 2019. Not that it, we're not talking about splitting the atom here to figure out that, in 2019, AMD had a roadmap that was really compelling. We will need to effectively pick apart. From our perspective, it's like, boy, AMD's looking really, really interesting, and an MI300A sled or its follow-ons seem like it would be really, really compelling. And I do think that if this is as big as its proponents say, if LLMs, if generative AI is as big a revolution as we have seen since the personal computer, since the internet, since open source. Those are some of the big revolutions that we have seen. If it's up there with those revolutions, and I think it might be. Like I'm not. We did a podcast episode recently with Simon Willison. If folks haven't listened to Simon, he's extraordinary. I love Simon because he's on this knife edge of like still of seeing all this possibility in the world while still seeing all the limitations of extant LLMs. But boy, there's a lot of possibility and things are really, really interesting. If it is as big as its proponents say, then I think that it's going to be really interesting for these next couple of years because there's going to be I think a profound desire for people to own and operate this compute because it is so expensive to rent.
So if you had access, you don't have access to them, but if you had access to them, would you put in Apple M3?
That's interesting because that is that is the same APU approach. Apple has also taken this approach. I mean, I actually, and I think in many ways,
they're amazing for us who have Apple laptops.
Amazing, and I mean, I think it's really not at all out of bounds to say we are trying to do for the server space what Apple did on your laptop and desktop. Apple took it and your phone. Apple took a unified hardware software approach and they unified system software, right? You don't buy an Apple laptop and then run an arbitrary operating system on it. You run the operating system that it comes with. You don't buy an iPhone and put another operating system on it. You run the system that it comes with, and it creates a delightful experience. And that is what we are trying to do in the on-prem DC space, is deliver that delightful experience, which delight is not a word that people have really associated with the server space. And we know that it can be delightful and uplifting, and you can go from a rack rolling off of a truck and into a DC and have that thing powered up, provisioned VMs within hours, as opposed to days, weeks, months.
So the first version of Oxide, I assume, is out, and you have some early users.
That's right.
Do
Yep.
you have any, can you share any kind of at a high level, just categories of use cases and workloads that people are?
Yeah. Yes, we did. We've seen a bunch of early patterns emerge. So we've got kind of patterns in terms of verticals and patterns in terms of use cases, and those are kind of crisscrossing. Certainly, the folks that have had to be on-prem for either for regulatory reasons or risk management reasons, those are kind of our earliest customers. As you can imagine, folks who are in that kind of in the federal space, in the financial services space, in regulated spaces, in the retail space, where you've got there is some enmity towards AWS, needless to say. So in those kind of like those traditional on-prem spaces, those are kind of some of our earliest customers. In terms of use cases, what all these folks often have in common is that there is a platform group who has responsibility for infrastructure internally, and they need to, if a new group comes along with a new demand, they've got to go provision up compute. And historically, certainly for the on-prem space, that provisioning of new compute has meant like buying new servers, especially when you need multi-tenancy. So the ability to like spin up a new tenant and be able to do something new and interesting. And those workloads, there actually been a lot of CPU-based inference workloads, and their ability to spin up quickly, provision quickly, that becomes a real difference maker, because especially when you look at CPU-based inference, where it's going to require perhaps more CPUs to get done, you need to be able to provision a bunch of them quickly. And it's like, look, I'm going to need 1,000 cores, but I'm only going to need them for 6 hours. So I want to be able to spin up 1,000 cores, run my job, and then spin that all the way down and be ready for the next one. And that is, that requires elastic infrastructure. That has historically required a lot of software that's not really amenable to that kind of programmability. So we have seen,
And honestly, so ML is not just generative AI. There's a lot of ML inference that are naturally being done on CPUs anyway.
that's right. That's right. And
Recommendations and those kinds of things. And what about Brian? So then I assume web applications is another category. And what about analytics? Data warehouse, data lakehouse.
is one of great interest. I think that we are we're in early days in that regard, and those folks. But yes, we've got a lot of folks. The folks that got big analytics workloads and big storage demands are definitely interested, because we got a bunch of folks also that are historic VMware customers. VMware has been acquired by Broadcom. Folks in the software space are not necessarily that familiar with Broadcom. If you've dealt with them, if you're in the networking space, or you've dealt with Broadcom, and it's like, this is one of those where it's like anyone who's got any kind of hardware experience can be like, yeah, we can tell you what's coming, because we know how this company handles itself, and it's not, from a customer perspective, it's not going to be good, and that's unfolding pretty quickly. So we're seeing a lot of what we knew would happen is happening pretty quickly, and you've got VMware customers are all thinking like, God, like, get me out of here. And what can I go do? What's next? And they're kind of, another thing we're hearing from folks is like, hey, I got a bunch of VMware. I've also got a bunch of these inferencing workloads that I'm now interested in. I am getting a bunch of ML. Like, is there a way I can kind of solve both of these problems at once? And then kind of landing in Oxide's lap, which has been exciting. So a lot of exciting conversations there.
So how different is Oxide for a user, UX and APIs and
yeah, so this is something that we really have been focusing on, because we are, we're kind of born as, we've done our own hardware, but that is a competence that we really had to build. We're really born on the cloud as a team. So it's really a point of pride that the developer experience is really delightful. So we've got anything you can do via either a web console or an API or a CLI. All that's driven via open API. So we're able to auto-generate all of this stuff, auto-generate kind of one from the other. We actually had a fun podcast episode where we talked about like what is the front end of the computer and how we are using open API to make that really quick for us to develop, and then easy for people to adopt bunch of SDKs out there for people to be able to easily tie into their provisioning infrastructure. And then it's all open source. Oxide is all open source. So people can see exactly how we've done what we've done. And another thing that's been fun is like where we're not providing that, or where there's an opportunities for improvement in the developer experience, people can see what we've done and can actually contribute and participate if they want to. So we've already seen a little bit of that, which has been fun.
So I imagine you've had to learn a lot about geopolitics and global supply chains and export controls and things like that.
Yeah, a little bit. I mean, a little bit. So less than you might think. So we are manufactured in the US, actually. So our board design, clearly the AMD
But
parts are coming.
that silicon has to come from Asia, right?
That silicon obviously is TSMC. That's obviously coming from that one.
Yeah.
So the silicon is coming from TSMC. And there's certainly plenty of parts that are coming from the Pacific Rim. But our manufacturing and assembly is actually in Rochester, Minnesota.
And maybe some of that silicon will start coming from Arizona
maybe. Yeah, maybe. Certainly we are. I've got kind of mixed feelings on that because I think that there's a danger where people can kind of revert to this nationalism in lieu of making better products.
Right.
And it reminds me, again, you and I are of similar vintage, and remember the way that there was in the 80s, American auto manufacturers made terrible products, and they wanted to kind of retreat to nationalism to force everyone to buy their cars. It's like, sorry, I want to buy a Toyota. And they kind of began to realize that actually we need to make better cars. Also, Toyota realized actually we should have a plant in the US. And you see that I kind of think that there's something similar here. You're going to see some of that. But from our perspective, the reason that we wanted to do manufacturing in the US is because that allowed us to pull on an entire ecosystem in the Midwest, in particular in Minnesota, and then it allowed our engineers to be on the line, to be sitting with folks in manufacturing, so we could actually debug our own manufacturing, debug our own supply chains. That's been really important to be onshore. So not onshore from an export control perspective, but onshore from a time to develop perspective and the ability to develop a very complicated product with a very, very, very small team. In terms of supply chain, that's also been very eye-opening because we were born kind of right before the big supply chain crunch. And we've taken a very different approach that I kind of alluded to earlier at Oxide, where we don't dual source absolutely everything. You would think that I want to dual source every component. So I've got 2 options for every component. And the problem is that if you do that, then you are effectively dual sourcing your architecture, and you are unwilling to build the software you need to build to really take advantage of someone's particular differentiated value. And you're really much better off picking one of those winners. And that was kind of our disposition when we started the company. I couldn't mention that earlier. So that really paid off with the supply chain. This was kind of surprising to me because we had gone all in on these various suppliers. When our fan provider, Sanyo Denki, we had a supply chain issue. And Sanyo Denki, because we are all in Sanyo Denki, when Sanyo Denki, actually, we were able to really partner deeply with them and let's take apart this bomb. Let's figure out where the supply chain problem is coming from, and let's work together to resolve that problem. And in this particular case, it's always a FET. It was a TI FET, which feels like it always is. There's always one FET that is the reason that for want of a nail, they can't ship but we were able to help them source this FET and resolve the supply chain issue. And that was only possible because of this deep partnership that we had. So that's been really, really essential for us to resolve the supply chain problems when they arise.
So at this stage, are you, I guess, for lack of a better term, GA, or are you still kind of vetting these early users and customers? And finally, is there an ideal user customer at this stage of the company?
So we are absolutely general availability, and I think that the ideal user. Well, so first of all, I think one thing that's important is we are not an important kind of constraint on rack level design. we're not you can't buy just like one computer here. Like you're gonna buy a rack full of compute. So if buying a rack is not in if that's kind of too much, definitely understand. But it's like it's folks that are going to be buying by the rack that are at this stage. I mean, I think that boy, if we ever make a product that is usable by the home lab, it will be explosive. We've got so many home labbers who are like, when do I get an Oxide home lab? It's like, well, when do you get 15 kilowatts into your basement? But at this stage, we're really looking for folks that are going to be buying a bunch more compute. So if you are buying compute at that scale, you're already in pain dealing with firmware upgrades and all this other cabling and all this other kind of nonsense. And I would say that if you're buying general purpose compute and you're buying it at any kind of scale, and you're frustrated with poor developer experience, especially if you're trying to offer multiple tenancy within an infrastructure group, we'd love to talk with you. That's a kind of a perfect use case.
And all the firmware updates, I imagine, are delivered over the wire, right?
That's right. That's a way, and we don't have. I mean, we don't have a UEFI bias. We are the only computer manufacturer that does not have a UEFI bias. So when you see these UEFI vulnerabilities, it's like, yeah, we don't have that. We literally just don't have that. And we've got our own service processor. It runs our own Rust-based operating system that's all open source that you can see inside. So it's like, yes, we are delivering all the firmware updates to you because there's just a lot less firmware to deal with.
So what's the timeline for this AMD GPU?
That's a great question. So I think that it's a bit of a question for AMD too. That's part of our next gen sled, which is under development right now. And we're it's top priority for us, looking to get that out sometime next year. I would stop short of committing to the MI300A sled, but it's something that we've got a very, very close eye on. We're very interested in. We're doing a Turin-based sled now, which we're very excited about. But we're because it is a big bet, we're trying to learn as much as we can about the space, and trying to figure out, where is exactly ROCm is relative to these other things, but really excited and bullish about where AMD is and is going here.
By the way, another argument for at some point doing GPUs is, I don't know if you've been following the web GPU standard, right? So it's a standard that provides access to GPUs in web browsers.
Oh, interesting.
Yeah. So lots of possible use cases there. Obviously, there's the ML inference, scientific visualization, and people now are building startups that can do basically video editing, real-time video processing, right? So you can edit your movie through a browser, kind of thing.
Oh, wow. That'd be cool.
Yeah. So there might be, and then who knows, the virtual world kind of application. So as that matures, as that standard grows in adoption, GPU usage will also be driven by these sort of applications, not just ML.
Oh, well, for sure. And I think that, this is not a deep thought, but the GPU is here to stay as a kind of a first class resident of the ecosystem, obviously. And I think bringing that on package, as Apple has done, as AMD is doing, is just very clearly the right trajectory for the industry.
And with that, thank you, Bryan.
Thank you, Ben. It's been great to be here.